Let's do a calculation, pH calculation of a weak acid. And in this case here, I've got it. Calculate the pH of a 1.00 molar solution of HF. And then look, we're given a Ka value. So that's another clue that this has to be a weak acid. In this previous problem with nitric, there was no Ka value given. And because there's no Ka value, it can't be a weak acid. But here we were given a Ka value, so we're going to treat it like a weak acid. And to do that, we're going to make a Rice table. Okay, so let's set that up. R-I-C-E. So our reaction is HF. Okay, and we can write these reactions in the simple abbreviated way where we omit water. So H plus F minus. Okay, so that's our reaction. We'll set up our little grid here. Okay, so now our initial concentration is that 1.00 molar. And so we can assume that that's 0 and that's 0 because we weren't told anything about it. And we recognize this change is going to be minus x. This is going to be plus x. This is going to be plus x. And so now this is 1.00 minus x. This is x. And this is x. Okay. And so now, as we inspect this problem, we could see here that I could easily do this problem, setting it up, right? We know 7.2 times 10 minus 4. It's going to equal our equilibrium expression, which is H plus times F minus, all divided by HF. And we recognize here we can plug in these values. But before we even do that, I want to point out here that, look, we've got a crazy small Ka, 7.0 times 10 minus 4, that's a small number, and a large acid concentration. And so let's back up a couple slides here. Look, we talked about how the more concentrated our weak acid is, the more likely it's going to pass the 5% rule. And that's exactly what we have going on here in this calculation. 1.00 molar and 7.2 times 10 minus 4. So I'm going to make the 5% rule assumption, which is up here. I'm going to assume that 1.00 minus x is just approximately 1.00. Okay? And that's going to make calculating this a breeze, as you will see. So 7.2 times 10 minus 4 equals, we know H is x and F minus is x. And our HF, we're just assuming is 1.00. So you can see this is very straightforward. If I finish off this algebra, so that's 7.2 times 10 minus 4 equals x squared. And all I got to do is take the square root of both sides. And when I do that, I get the following. So we'll say 7.2 times 10 to the minus 4. Okay, I like to push the equals just so I know I get the number in there. And then I'm just going to push the square root button. And lovely, I get, with 2 significant digits, that's 0.027. And so now we kind of have to ask ourselves, what does that 0.027 mean? Well, there it is, okay? So that means that it's 0.027 molar. So is the F minus, but we don't care about the F minus because we were just asked to calculate pH. And now that we know what the H plus is, okay, we can just simply say that pH equals the negative log of the H plus concentration, which is 0.027. And when I do that calculation, I'm going to get the following. Okay. So, oops, I suppose I could have left it in the calculator because it had more of the digits in there. That's okay. We'll just do it like this. So log. And then I know that I can just multiply that by -1 in my head. So now that equals 1.57. And there's an interesting Sig Fig rule with logs, and I'll just describe that to you guys orally, okay? The number of Sig Figs inside the log, okay? So number of Sig Figs inside log equals number of decimal points. Okay? So look, I had 2 sig figs inside the log. The leading zeros are not significant. So there's 1, 2 sig figs inside the log, and now I end up with 1, 2 decimal points in my final calculation. That's how the log rule works with sig figs. Okay? So now, we don't know if this is our final answer or not because we do need to test the 5% rule. And so our 5% rule says we take the value of x, we divide it by the initial acid concentration, and we hope that that's less than 5%. Okay? So all of that's going to equal 0.027, that was the value of x, divided by 1.00, which is my HA concentration. And I can tell you right now that equals 2.7%. So that passes the 5% rule. And we can see our pH is 1.57. I also want to point out that HF, even though it's a weak acid, it can still make a very acidic solution. 1.57 is very acidic, okay? It's more acidic than your stomach acid, right? And the reason why that HF can make such an acidic solution is because 1.00 molar is a pretty large concentration, even for a weak acid.